Hello and welcome back. Today I'm going to be focusing on function overloading. And function overloading, as you can see, refers to using the same function name, and the functions just only differ by in the type of parameters that are passed, or maybe even the number of parameters. The return type is not taken into consideration. So the compiler is going to differentiate only based on the type and the number of input parameters. Where does function overloading come in? Or where would you see it being helpful? Could be in a problem domain where you are attacking the same problem, with the same algorithm across different types of input data. So you could be, inputs could be strings, or it could be numbers, or it could be a different data type. So that's where function overloading comes into the picture. So here I've got, as you can see, I've got a few. I've got an add function, a very simple add function. So I've also got some starter code here where it accepts inputs, integer inputs, and I'm calling the first add function. So as you can see here, I'm just, at this, anyone reads this code, they're not going to be able to figure out which version of the function is going to get called. So let's take a look and see which is going to get called. The compiler obviously would be able to pick the correct function. So let's run this program and see how it's going to. As you can see, we are being prompted here. So let's enter two integer values. So let me enter 2 and 3. So it's printed the message calling add int. So that's this one. So as you can see, the compiler has generated code based on the type of parameters that we passed, and the compiler knows that it should be actually calling this version of the add function. So let's exit this, and let me also now try adding maybe like using a double. So let's say 23.2, and b is equal to, say, some other value, and let me call add with a comma b. Let's see what our output is going to be like. Let me actually let me retain this. It's going to help us see how the functions get called. So as usual, I'm going to pass in two integer values, and you can see call add in 5, and then there's the call to the add double. All right, and we have 61.5. So that's 23 and 38. It gives you 61.5. So as you can see, it's called add double. So for the sake of completeness, let me also use f1 equal to 23.4. Let's use let's use 100.5 f, and f2 is equal to maybe 200.6 f, and let's call add with f1 and f2. Let's pass 0.5, and it's lo and behold. So 4 plus 5, you call add int, and then it calls the add double for these two parameters that we um, defined out here, and then we define two float parameters, then we call the add function. So as you can see, 100 plus 200, it's called the add float, and you got 301. So that's it, folks. I mean, it's a very useful and important topic, and function overloading has many applications. This is just an eye-opener into the topic. I would suggest that you look at it from the class point of view as well. So if you define classes, you could still use overloaded functions within each of your classes. But the key thing to remember is that overloading always happens based on the type and the number of parameters. And there's also one other thing that I would like to bring up when it comes to, for instance, let's say we have something like display, and I say const string, and I have another display which says string, which just accepts only just a string reference. Now, here, as you can see, the compiler would consider both these as two different functions. So this is also an example of overloading. You can overload on constness. All right. The other thing that I would like to mention here is the compiler doesn't really care about the names of the parameters that you're using. So you could say S1 and then you could say S2. Now this is not overloading, right? Because the compiler only takes the parameter type into consideration. So this function only the compiler only sees two functions which are both taking the type string and then both taking a reference to a string. So the compiler would consider both these functions as one and the same. All right, folks, that's it, and I'll see you in the next lecture.